Now let us try to see the response of this series LCR circuit. As you see, we have switched on that multi waveform signal generator. What we have done here is that we have chosen the sine function. This is sine function. Next is that the selected range is 20 kilohertz. Why did I choose 20 kilohertz? It is because my estimated resonant frequency is about 11 kilohertz. I can show you the calculation. From here I put the value of inductor as 20 millihenry and capacitance 10 nanofarad, and the calculation shows me something 11.26 kilohertz as your resonant frequency. We will now try to see what is the response of this or LCR circuit. This is our LCR circuit to this particular frequencies which we are going to scan now. Let me tell you is that I have put one AC voltmeter as digital meter here, one digital multimeter. We have range, I have put 2 volt range. By checking, I have found it very suitable to record, and this is our circuit. No problem with that, it is working very fine. Let us see the variation. At 5.4 kilohertz, the value is 0.3939 about steady value. So, for fluctuations you will have to avoid and you have to note down the values. How will you note down? You see, say it is 5.6 or 5.3. So, the corresponding value you will have to note down to be 0.298. The fluctuations you will have to avoid, then only you will get correct result. And here we will vary this knob to get different values here. See, 6.2, 3.9, then 6.6. the value increases as I increase the applied frequency. 10, it has become 1.3 the voltage value, then after 10 it is 11, 1.8, and see it is decreasing. 11.52 it decreases. If I do more than that, 12 it further keeps going down, 13 it goes down, 14 it goes down, 16 it goes down, 17 also it is consecutively decreasing. What is the meaning of this? The meaning is that here I am changing this, you can see here this knob, coarse, fine I am not using right now, this is fine button. One thing is very much clear is that we have a resonance around 11. You will see, although it is fluctuating but still around 11, it is 12, 11 and this is 11. I will now use fine button. It goes down, you see. The near 11 we have the resonance, in this case this value 11.4, 11.2. my theoretical calculation says 11.2. after that let us see, yes it goes down. If I increase, the value goes down. So, it is about 11.2 this resonance is. How will you do? How will you perform? You will record the values one by one. You will record as per your suitable value at 3.9.203. I will show. This is the table. You have frequency say 3.9, applied voltage I am getting it at 3.9, I am getting at 0.199. Current I will find by dividing. Next you change, you make it 5.0, 0.306, 5.0, 0.306. That way one by one you will take readings. For this combination we are taking reading now. R1 equals to 150 ohm, L 20 millihenry and capacitance is 10 nanofarad. You will take readings by consecutive frequencies. Here you will carry this, and near this 11 you can use that fine option. Make this fine option run near that 11 so that you can fix or you can get the frequency much better way. That is, more readings near 11 you can take. Here you can jump from 4, you can take 5, then next you can take 6, and that way you continue up to your suitable range. Say I can take here from 5 to 12, last reading may be 12, up to that we are taking here in kilohertz, frequency in kilohertz. Okay. So, this is our instrument, and for this setup you will change the values of the applied frequency and you do the recording. Okay. And you can check what is the voltage here, 14.1, around that peak to peak voltage is here. I will record this VPP to be 14.1, this VPP value to be 14.1, and you see this resistance, we have a resistance here, this resistance is 150 ohm. You take more resistance, another additional resistance I have here, this is also 150. I will put these two in series, then I can make 300 ohm total for next reading. This reading, change of frequency and your applied and obtained voltage. What voltage you are getting? Root mean square voltage, and this is your applied frequency. All right. So, this is how we are going to perform this experiment for 3 different setups and then plot the graph.